I wanted to add a data port to the Kenwood TM-281a so that I could send APRS messages and receive them. Of course, the model does not have a data port. There's lots of instructions on the internet on how to do this, but I didn't see any videos, so I thought I'd make one of mine. You can see it here. It's that white cable that goes into the back of the radio. The basic setup of what I'm going for is shown here. The radio talks to the Raspberry Pi with 4 wires. There's an audio in and an audio out, shared ground, and then I still needed a push to talk. So this will involve soldering 4 wires into the radio because the microphone jack does not provide audio out. So if it did, this would be much easier. So I'm kicking myself for not making a video of this, but really if you're going to solder a radio, then opening it up is not going to be a problem. It's just screws on the side and the lid pops off. I did drill a small hole in the back for the wires to come through. I also used some tape with the sticky side out in order to catch any metal shavings so that I wouldn't have any short circuits in the radio. I brought 4 wires in. You can see the black wire is a ground and it just solders onto that post. The green wire goes to a port marked DTMF in, which is actually the discriminator audio out, which means that it's the audio that's at a constant level and before any PLL or CTSS tones are applied, which is perfect for this, which means that when you've got APRS or whatever working on into the Raspberry Pi, you can actually have the volume turned all the way down on your radio so you don't have to listen to it. That DTMF in port is very small. It's not even a solder pad. It looks like a via that's a test point at the factory. So the soldering is not hard, but there's really not much for the wire to hold on to. So that's why I put zip ties on both sides of the cable coming in and out of the chassis so that it would have some strain relief because solder is not a mechanical connection. For push to talk and the microphone in, I ran the wires through the front of the chassis through the faceplate. The faceplate pops right off. If just be gentle. There's a ribbon cable that there's already a hole for it, so you can follow it with the cable, and then simply pick up those 2 solder points, which are the backs of the plug for the microphone itself, and you get push to talk and microphone. After that, I crimped the connectors coming at the back with a DuPont style connector, 4x1, so that I didn't have to keep that long cable sticking out of it. I could just plug it in as needed. The push to talk was also a bit of a issue because I'm using a Raspberry Pi and the GPIOs are 3.3 volts, but my relay is a 5-volt relay. So I needed to use the circuit above to have 3.3 volts control 5 volts, and then the 5 volts control the push to talk, which really just requires that you use the ground connection you pick up off the radio to ground out the push to talk line. But because it was a radio and because I didn't want to fire my Pi, I wanted a mechanical switch like a relay instead of wiring it directly into something. Either way, the circuit was pretty simple, and the Raspberry Pi I also used DuPont connectors to pick up that 5-volt power ground and pin 14, or rather BCM 14, which is actually pin 8. So then I made another cable that has the male pins that fit that DuPont connector, and then on the other end broke it out into the TRS connector, which is going to go into my sound card. Left to right, the pins on that connector are microphone, there's a blank, there's ground, and then that's the microphone in, which corresponds to the speaker out from the radio. I then took the ground connection from the circuit that controls the relay, connected it to that third pin of ground, and then pulled push to talk off that wire and wired it into the relay circuit. Then that TRS connector goes into the sound card that's on the Pi, and after that it's a matter of configuring the software, which we'll have to wait for another time.